Hi there! In this video, we will discuss light refraction and its effect on our everyday view of the world. We will show how upward light refraction produces a sinking effect, which causes apparent obstruction of distant objects across horizontal surfaces. These observations are testable and repeatable. They can be conducted in all sorts of weather conditions throughout all times of the year. We've shown in previous videos how closely the rate of bottom-up disappearance with our RC boats on small bodies of water matches what we witness with large boats on large bodies of water. And as we've pointed out before, we know that with our observations, curvature of the Earth cannot be the cause of obstruction that is witnessed. The bodies of water we use are usually no more than 600 feet. And at 600 feet, there would only be approximately 1/10 of an inch of curvature drop on a sphere of our given radius. And from our viewing height of approximately 1.5 inches, the geometric horizon would be over 2,200 feet away. These observations are backed by other researchers, such as Wide Awake, Good Times for All, this observation by Pebbles in the Pond, and this footage here by Life is Short. As you can see, even on a calm day, without waves and no visible inferior mirage, the distant object still disappears from view as the camera is lowered, and at a distance of only 400 feet. From conducting these observations for a few years now, it has become clear that upward refraction is very common and consistently occurs in various weather conditions throughout the year. Sometimes, like in this footage, upward refraction is clear to see as the boat disappears bottom up into an obvious inferior mirage. The temperature difference between the air and the water was a little more than 5 degrees. On this day, the temperature difference is around 3 or 4 degrees, and the boat again disappears bottom up into a more subtle inferior mirage. And here, on a day with only a couple of degrees of difference between the air and water, the boat once again disappears bottom up as it moves away, even though there appears to be no sign of a mirage taking place. If this were a large boat on a large body of water, this footage would undoubtedly be used as evidence of the Earth's curvature. This is the most subtle of inferior mirages. This slight sinking effect presents the illusion that the hull of the boat has traveled below the horizon. We've also shown how compression can lead to objects disappearing bottom up as they move away from the viewer, even on days that you would expect to witness downward light refraction, with the temperature inversion of hot air above a layer of cooler air and even cooler water. So again, even when the temperature of the air layers above the water and the temperature of the water itself is very minimal in variation, we usually witness slight upward refraction. And this refraction does not allow the light from the distant objects to arrive to the viewer in full. Only in certain conditions are we able to see the distant objects in full. As you can see, distant objects are consistently hidden from view in various atmospheric conditions and throughout the year, both day and night. And when you compare these observations to what we see with boats at sea or sailing on large lakes, you notice a lot of similarities. Here are some at-home observations that also show upward refraction at work. All we do here is let the outdoor environment mix with our indoor environment by opening our patio door. These observations can be conducted many different ways and in different weather conditions. Since we're viewing from 1 1/4 of an inch, well above the surface relative to the distance of the objects, which are less than 20 feet from the viewer, we found that we need around 30 degrees Fahrenheit of temperature difference between the indoor and outdoor environments to see drastic effects. Though we have seen very subtle effects with temperature difference as low as 15 degrees at this short distance. Again, what we witness on a large scale with bottom-up obstruction of objects with an increase in distance from the viewer, we also witness at home in our living room. The distant objects are refracted the most, while the closest objects are affected the least. This upward refraction causes the appearance of bottom-up obstruction of objects with an increase in distance from the viewer, and also presents a false horizon which appears much closer to the viewer than the original horizon, which was created by the floor meeting the far wall. And much like we see on the large scale, by raising our viewer height, the light from the objects arrives in full. This great observation by Matthias K.P. shows the bottom of turning torso and other distant buildings below the horizon. The viewer height was just over 12 feet, and the buildings were approximately 15.5 miles away. There was very little temperature variation of the air and water during this observation, therefore no obvious inferior mirage or compression taking place. Is this definitive proof of the Earth's curvature? Or could this be the same subtle upward refraction effect we've witnessed on small horizontal bodies of water, now happening across a large horizontal body of water? We do not live in a vacuum, and so there will always be some level of refraction occurring in our atmosphere. Upward refraction is very common and even occurs with very little temperature variation in the layers of air above the surface. Could upward refraction be the reason we've concluded the Earth to be a sphere with a radius of 3,959 miles? Is it possible that the Earth could be a larger sphere than we currently believe, and that upward refraction exaggerates the curvature, making the Earth appear much smaller than it actually is? Or could it be that upward refraction creates the illusion of curvature when there is no curvature present at all, with a horizon that is truly horizontal? Just some things to ponder. Thanks for watching.